Hi everyone, welcome to my first of 3 factoring videos. We're going to separate these out into how many terms are in the polynomials. So today's video is going to be all about polynomials with 2 terms, or binomials. I will give you guys a time at the end of the video to copy this down, but I just want to show you, if you're using this graphic organizer, we are talking about the 2 binomial methods of factoring. And then in the second video, we'll go over 3 terms, and then 4 terms for the last one. Okay, so we'll come back to this. Let's talk about factoring real quick, just because this is the first of the 3 videos. What is factoring? So in really simple terms, factoring is just the opposite of multiplying. So we're going to talk about what factors multiply to give us a polynomial. So let's go in the direction that we're used to moving in. So normally I would ask you, hey, multiply these, and we would get x squared plus 4x minus 3x, and then minus 12, right? And then I'd ask you to simplify that. So then you'd have x squared plus x minus 12. Now, this polynomial right here is what you're going to be given as your original problem when we're going through factoring problems. So normally we're used to going in this direction, multiplying. Now we're going to go in the opposite direction. You're going to be given a polynomial, and we're going to write it in factored form. So really we're just going back to where we started. X plus 4 and x minus 3, like that. So this half is what we're doing today in factoring. This half is what we have been doing when we were multiplying our polynomials. Alrighty, why do we need factoring? There's a lot of uses for factoring. Ones that we'll use in this class a lot are if we're dividing polynomials. Also, when we are working with rational functions, I didn't even write that here. When we're graphing polynomials, it helps us with our algebra skills. So a lot of different reasons that we factor things. And then the third and one of the most important parts of factoring is no matter what polynomial you are given, always, always, always factor out a greatest common factor first if you can. So this is going to be your first step to factoring, no matter what your polynomial looks like. It's not always going to apply. Sometimes you won't have a greatest common factor, but you always, always, always look for it. That's going to be your first step no matter what. Okay, with that out of the way, let's talk about our 2 ways that we're going to factor a binomial. So remember, that means if we have 2 terms in the polynomial. The first common binomial that we're going to have is a difference of squares. So I'll let you write down this kind of bulk of our rule. But anytime we have a difference of squares, so that means the 2 terms are both perfect squares and there's a subtraction in between. Notice I did not say sum of squares, so this rule does not work if it's added. Just to remind you guys, the difference between squares and cubes. Squares are everything we can take the square root of and we get a nice whole number. And then cubes, we can take the cube root of all of these and we get a nice whole number. So these are our perfect squares. I put dot, dot, dot. Obviously, there's an infinite amount of them. And then cubes. These are the ones you should probably look for most. But yeah, these are our squares and cubes, just to remind you guys. Okay, so if we have a binomial and we can see that both terms are perfect squares and there's subtraction in between, then we can always factor it as a plus b and a minus b. Now this is just a general rule. That's why we're using a and b. Sometimes you're going to have numbers, sometimes you're going to have x, y, doesn't matter. But this is just for a general rule to show you that you take the square root of this number and the square root of this one. You write that here and here. And then one of our factors is going to have addition, one of them is going to have subtraction. And we will always be able to factor a difference of squares like this. So with the rule covered, let's try it out with some actual examples. So let's move into, we're just going to do 2 together, and I'll give you a moment to jot that down, or if you want to pause that, those are the 2 we're going to do together. The first one is y squared minus 16. So quickly, we would just want to make sure that these are in fact perfect squares. Yep, and yes, and it's subtraction. Okay, so now we're going to use our rule. I'm going to write my 2 factors. Remember, factors just mean when you divide something by a number, a factor is what it multiplied by to get to that number. So, you know, factors of 2 are 1 and 2. Factors of 5 are 1 and 5, like that. But anyways, we have our two factors. These are the two values that are multiplied together. One of them is going to be a plus b, and one of them is a minus b. Let's think about what our a is. The square root of y squared is just y, so that's our a value. The square root of 16 is 4, so that's our b value. And then remember, one of these is going to be addition and one is subtraction. It's as easy as that. So that's a completely factored version of this polynomial. So what that means in math is if I were to multiply this out, then I would get this answer right here. All right, let's try it again. This time we do not have a coefficient of 1, and we also have z to the 4th. So again, let's ask ourselves, are these in fact perfect squares? Well, this one is, I could say my a value is 2z squared, right? If I multiply that by itself, we get this value. And then 1 is a perfect square as well. B is 1, right? Because 1 times 1 is 1. Okay, so we've checked to make sure that it's a difference of squares. We can now start to use our rule. So I'm going to write out my parentheses. I'm going to write my a term, so 2z squared, 2z squared. I'm going to write my b term, 1 and 1. And then remember, 1's going to be addition, 1's going to be subtraction. Something I really want you guys to look out for. 3 kind of main things to do when factoring. The first one, factor out our GCF. So we already talked about that no matter what. The second is ask yourself how many terms there are. So we talked about how to factor if there's 2 terms. The last thing is always ask yourself, am I done? Right? So here I have a sum of 2 values, so that's not one of my difference of square rules. And here I do have a difference of 2 values, but 2 is not a perfect square, this 2 right here. So even though I have z squared, this is just times 2. So remember, 2 was not on my list of perfect squares. And so we are done factoring this. We cannot go any further. All right, so that is a couple problems on difference of squares. Now what happens if the 2 values are cubes? So again, thinking about our perfect cubes, if we see 1, 8, 27, 64, and so on, those are perfect cubes. Let's talk about the rule. So let me zoom out a little so you can get this all in. Our rule acts similarly to before. So anytime we have a difference of cubes or a sum of cubes, we have a special rule on how to factor it. Okay, so hopefully you paused that if you wanted to jot that down. Let's get into how to write down this rule. If I have a difference of cubes, the first factor is my a value, my b value, and then whatever the sign is. So it's going to be the same subtraction. Then my other factor is going to be the a value squared. Then I'm going to write the opposite sign. So since this was subtraction, I'm going to write addition, a times b. And then this one is always addition. And then I have b squared. So again, we'll see how this works for a specific problem, but it's really good just to write down like the generic rule, just so you guys have that down. This rule is exactly the same if it's the sum, and so we'll see what that means in the parentheses. So again, a, b, and then the same sign, using the same rules up here, so it's plus this time. We've got a squared, then it's the opposite sign, so negative ab. And then remember, always plus b squared. So notice the rules are very similar. The only thing that changes is the sign here and here. So with difference of squares, you can only do the difference. With cubes, you can do the sum or the difference. Okay, so hopefully you got that rule down. We're going to try this with one example, and then you guys will move on to trying some on your own. Okay, so the difference of cubes that I have here is 8x to the third minus 27. Actually, it's a little too much. So we are going to factor this. I'm going to check to make sure, okay, good, I have a cube here, and this is a perfect cube as well. I'm going to write out my parentheses so I can use my rule to factor this. And I'm going to go ahead and point out my a value and my b value. It's a little better to write that down for these ones. since we're going to be multiplying some terms together. So a here, we'll have to think about what is the cube root. Cube root of 8 is 2, and the cube root of x to the third is just x. So this is my a value. And then my cube root of 27 is 3. So now I've got my two values. All right, so let's get started writing the rule. The first one is a minus b, because it's the same sign, 2x minus b. The next one is a squared, so I'm going to have 2x squared. I'm going to simplify this later. Then I'm going to write the opposite sign, plus, and then a times b, and then always plus, and then b squared. Ran out of room a little bit. So let me zoom in what I have here, and then we're going to simplify underneath just so this looks a little prettier. Okay, so this one we're just going to keep the same, 2x minus 3, and then I'm just actually going to multiply here and here so that I have a value. So 2x squared, that's going to be 4x squared. Then I'm going to multiply these, that's a 6x, and then 3 squared is just 9, like that. So I have factored this binomial into these two factors. This one is 1, this one is another. If I were to multiply these together, I would get back to this original binomial right here. So this is your answer. This is completely factored. We are going to talk about how to factor trinomials like this in the next video. So we're going to save this part in case we can factor that for the next video. But for now, just for this video's purpose, we are going to leave this as is. Okay, thanks for watching, guys.